Good evening. I'm here to talk about building a proxy server in Golang. So this is the main project that I'm working on DigitalOcean. Again, we're hiring. Check our careers page. I posted it on our Slack. So check the channel, click on the link, and apply for jobs. It's a really nice place to work. So what is a proxy server, right? It's this. You have someone that's sending a message on one end, and then it's going through a proxy or a collection of proxies. Like, it doesn't have to be just one, and then it's going to reach the other end. Like, ideally, you want the thing that was said in the beginning to arrive at the end, but sometimes you don't want that. Sometimes you want to change the message, sometimes you want to message the information, sometimes you want to change the information, add more information. So there's a bunch of stuff that could be done on proxy server, and it depends on what you're looking for. So if you're using the internet, you are using proxy servers. Like, it's extremely unlikely you're sending a request and it's not going through a proxy somewhere. So proxies are used like throughout the internet or any kind of network to add more functionality or to simplify the way you're going to interact with a lot of the other services. So the goal of the proxy server is that it's going to get a request, it's going to do something with the request, or it could just be a pass-through proxy, and it's just going to forward the request to someone else, to another computer on the other end. So there are just many different ways and many different things you could use.
So a proxy server is basically middleware?
Yeah. So it's going to show up in many different ways. You could have database proxies. If you are running something like PostgreSQL, you might have had to use a database proxy because of the way Postgres handles connections. So many times we're going to have PG pool that's sitting in front if you have like lots and lots of clients, or if you're running a lot of Rails applications that each opens one connection for every single process, then you probably want to have something like PG pool that's going to be doing proxying for connections for your database server, so that you're actually using the resources on the server as good as possible. You could have TCP proxies that are basically they just see TCP traffic on one end and they forward the TCP traffic to the other end. And you could have HTTP proxies, which is what we'll be talking about today. So they come in many flavors, but today we're going to be talking about HTTP. So why bother about with building something like this? Why do we do proxying for HTTP on DigitalOcean? First thing is that we do SSL termination, so we don't want to have the same SSL certificates throughout the whole infrastructure. We still do SSL internally on our services. We use a lot of gRPC, so all of our gRPC services, they speak over HTTPS, and so they handle their own SSL, but the main public SSL termination happens in the proxy. So we don't want our main certificate to be in the whole infrastructure. So pieces of the infrastructure have access only to the certificates that make sense to them. We have connection management. A lot of the stuff that's talking to us is talking over HTTP 1 or HTTP 1.1. So they're going to open many connections to do the work. But for our internal services, we can use HTTP 2. So we don't have to open many HTTP connections to the stuff that's internal. So while we talk to the outside world using HTTP 1 and HTTP 1.1, internally we can just speak HTTP 2. It makes much more sense and uses less resources. So there's security, there's auditing, there's load balancing, there's caching, there's compression. There's a lot of stuff that we can do on the many pieces of the proxying of our infrastructure. So we do all of them. And anything you can imagine, like a middleware, anything you can imagine as being done by a middleware could be done by a proxy on the environment that you're doing. So building HTTP proxies. So when you start building an HTTP proxy, you need to get a handle of how the protocol actually works and how proxies should behave on when they are handling HTTP traffic. There's a bunch of stuff that you have to care about when you're doing proxying over HTTP. There's a lot of the proxy headers that you have to fill in. There's the ones that are defined in a protocol. There's a bunch of other headers that are not well defined in a protocol, but a lot of frameworks are going to require. So you will have, while we do SSL termination on the outside, our Rails application that's running on the backend, that's what you see when you open the control panel on DigitalOcean. That's a Rails app. It uses cookie sessions, and they use secure cookies. Secure cookies will only run if you are running over HTTPS. But then the request that reaches Rails is not HTTPS. But so what we do is that we instruct Rails using a header, hey, this request came from HTTPS, so you can trust that it is actually a good request, and you can serve the cookie and do the work that you have to do. There's the upgrade that's going to upgrade the protocol that you're using. This is also used when you're doing WebSockets. So you send a common HTTP connection, then you do an upgrade, and it becomes a WebSockets connection. There's keep alive if you're running on an older version, like if you're running on HTTP 1, then you could have keep alives being sent. And the proxy, the keep alive is between the client and the proxy. You don't have to maintain the keep alive between the proxy and the stuff that's on the back end. Like the pieces that are on the back end, they don't have to replicate the keep alive. They can just decide what they're going to do with the keep alive. If they're going to maintain the collections, if they're going to throw out the connections. So there's a bunch of headers that you have to worry about when you're doing proxying that you have to remember. Is this a header that I should send downstream? Or is this a header that only makes sense to me as a proxy? So you have to consider this when you're building this kind of solution as well. And transfer encoding. So transfer encoding is mostly useful if you're streaming data. So if you're streaming data over HTTP, you will have to manage transfer encoding in a way or another. Most of the time, providers do not support transfer encoding. Why won't they support transfer encoding? Because that allows you to send an HTTP request and not say how large it's going to be. So you could easily fall to an attack, because people could just be pushing data and pushing data and pushing data, and then you never know when it's going to end. So if you try, for instance, to upload something to S3 on Amazon, our competition, they are not going to let you use transfer encoding. Because if you are uploading a file to S3, you must say the file size. So you're saying like, the length of this file is X, and I am uploading this file to you. S3 is not going to allow you to use transfer encoding and say, oh, let me string the file, and then you figure out the size. You count the bytes yourself, and you figure out the size. They're just going to say, no, we do not support this. And most of the time, you don't want to support something like this, unless you are actually doing streaming over HTTP. So you have to forward the original client headers. So this is the X-forwarded proto, X-forwarded host. So this is the information for the protocol that arrived. So if you got a request on HTTPS, and now you're sending this request over HTTP, you can send this information, like if you're for instance doing Rails, and you have Nginx in front of your Rails app. And Nginx is doing SSL termination, and it delivers the request to the Rails app. For the Rails app to know that it was actually an HTTPS request, you have to say it here. You have to send this downstream. So if you're configuring your Nginx for Rails or for any other kind of framework, you would have to send this downstream, and you also have to send the X-forwarded host. When you make an HTTP request, there's always the host header in there. When I am the proxy, the host is my address. So it's the proxy address, because it's the proxy that's sending the request to the downstream service. But what do I have to do? I also want to say that the actual client that made the request was someone else. Like, it's not me. I am forwarding a request on behalf of someone else. So you're going to send this information in here. So if you're building a proxy, you have to respect this kind of stuff. Otherwise, the applications that are downstream are not going to be happy. So if you were streaming data, transfer encoding chunked, I would not recommend anyone to do this unless, again, you're doing streaming. Otherwise, just say, no, I do not accept transfer encoding chunked, because this is not safe most of the time. And your servers are not going to be happy, and it's going to be really, really easy for someone to just swamp your servers, because you're just sending a lot of data and you are accepting all the data that they are sending. So there's always the content length, and you can always say if the length of your request is bigger than my limit, you can just deny, just send a response back and say, nope, not going to process this request. So it's a really simple way for you to add, like if you have a proxy on the beginning of the process, so someone sending a request reaches a proxy, you do not let this request enter your actual environment. You can just deny the request right in the beginning. So you have to be careful with impossible situations. So for this, you have to pay attention to how the protocol works. So you can't have content length and transfer encoding chunked both at the same time. Because when you say it's chunked, you don't know the size. And if you know the size, it can't be chunked. So if someone is trying to send this kind of request to you, it's probably an attack. It's either someone that has something really misconfigured or they are trying to do something bad to your service.
So I'm assuming you can't specify the size of the chunks individually?
No, you can't. Yeah. You will send, like, you're going to define a termination character, and this termination character is going to say, this is where it ends. Assume the worst all the time, because people are going to try many different things to figure out what's happening on your service. So like for instance, like the Cloudflare stuff where they were just leaking information and people could just load this data from machines. Always assume that someone is trying to attack you, and always try to prevent whatever is happening. We had a couple of days ago an issue where people were just sending requests using methods, HTTP methods that are not available, but we were still like showing error pages for that. Now we just say like not supported. There's no reason to show an error page or to provide people with the information that it errors when you send something that's unexpected. So try to remove all the unexpected pieces and always assume that people are trying to do something bad, because many times they might be trying to do something bad. So respect cache control headers. So if the client is sending cache control information to you, try to respect this information or send this downstream, because the downstream services might understand what this means and they will do whatever is needed. So if your proxy does not implement any kind of caching, ignore and send it downstream. If your proxy does have caching, like make sure you look at these headers and you respect the headers that the clients are sending to you. Be careful with buffers. So it's really easy when you're doing something in Go, like you're building your proxy server, you get your HTTP request, you use IOUtil, and you do a read all on the request body, and you did not look at the content length. And what's going to happen is that you're going to allocate all that memory in a byte buffer, and it's going to be on your server, which is like might be fine. Like your Golang process might be using like 10, 16, 20 megabytes. But then if a lot of people send requests all at the same time, you have a lot of large requests in memory. So when you're building something and when you're building a proxy server, try as much as possible not to read data that you do not need to read. And if you're going to read data, make sure there's a limit on how much data you're going to allocate. Because if you're just reading all the request body, like whenever you get a request, what's happening is that if someone sends something really large, they could cause a denial of service on your server. So you don't want something like this to happen. You don't want people to just send a collection, like from one machine, you send a bunch of large requests to your servers, and then all of your servers die, all at the same time. We had, this was a couple years ago. I think this was like 4 years ago, but Rails, when you send a request with a lot of keys, it will try to build hashes, because that's how the parameters parser works in Rails. It just builds a hash, and it was a hash with many keys, but like no values. It was just a lot of keys, and this made servers be really slow, because there was no limit on how many keys it was going to produce. So this led to the fact that you could cause a denial of service on any Rails application with a basic request that anyone could do. Like even your login page, it could work. Like it could just happen, because there was no limit. So if you're building a proxy, people will try to do something like this to you. So do not read stuff from buffers without a bound. Always define a limit for when you're trying to build stuff. Be specific when you fail. So no support for chunk request, just say length is required. Like provide an actual message saying, yes, you have to require a length to make a request in here. So request does not contain authentication details. It's unauthorized. So there's no authentication details at all, unauthorized. There are authentication details, but they are not valid. Now this is forbidden. So there is a difference between 401 and 403. 401 is there's nothing on the request, like 401, and then the browser tries again. Most of the time the browser is going to request the information from the user, is going to ask for a username and a password, and then it's going to send it. But otherwise, if you do have the authentication details and they are not valid, then it's forbidden. For this, the browser is not going to do anything. The browser is just going to say, hey, you don't have access to this. Use via and server to define where the responses are coming from. So if you are a proxy server, there is like the question of where am I getting, this is one of the issues that we have found, because we have a lot of services that are running behind our proxies. People will always ask, oh, I saw an error. Is it the error on your folks' proxy, or is it my application? So how do people figure this out? Like, the only way for people to figure this out is if when you're sending a response back, you say, who is providing the answer? Like, is the application that's failing with a 500, or is my proxy server that's failing with a 500? So if you should use the headers to provide this information, to say, oh, it's coming from the application, or it's coming from the actual proxy, so that people don't have to come into you and say, hey, is your service down, or is my service down? Log everything and do not log anything. So there is an issue here that we want to have as much information as possible, but we don't want to see like data that could identify users in our logs, because this is not nice. You don't want to see passwords, credit cards, or any kind of information on your log. So always assume that you cannot log information unless you are 100% sure there is nothing or no chance that information is going to be available that's going to allow you to identify users or leak information that's personal or sensitive to users. So when you're going to log, define the HTTP headers. There's a bunch of HTTP headers that you don't have to care about. Like they are basic and they're going to be there all the time. They're not going to allow you to figure out anything about the users. But any header that provides authentication information, any kind of request that's going to handle data that's coming from a browser, those are probably not safe to log. So you want to log the request, you want to log the request ID, you might want to log the status that you got back from the server, but you should be extremely careful when logging information about requests, especially request bodies and response bodies, because there could be actual data, like private data for users in there. So do not try to log only the stuff that you know it's like 100% safe to be logged. So why are we building our own proxy inside of DigitalOcean, right? Right, because it's fire all the way and we are just going insane and we have no idea what we're doing. Actually, it's because microservices. So what's happening is that we have our monolith. It's there, and we're trying to burn it with gasoline, diesel, and napalm, and whatever you can imagine, but it just won't die. So it's really hard to kill these things, and we're moving slowly in the direction of building this, but we have customers that are using the service right now, and we can just throw these people away. So what we're doing is that instead of just assuming we're going to rewrite, we are building new stuff out of the monolith as microservices, and we are providing like a way for people to migrate if they have stuff that's running on the monolith right now and they want to move it out. Then we have a way for them to do this. So how do we allow people to do this? There's a bunch of stuff that's independent of the application that you're building. We have customers. Customers have to pay, so they have to provide like credit card information. We have to understand how they stand. Like, are they abusive users? Are the users that we know like are trying to do something bad in the system? So we have what we call the edge gateway. That's the proxy that we have built, and it provides routing So when you send a request to anything inside of whatever is public on DigitalOcean, the very first thing that's going to hit is this thing. So I'm on call for this thing, so try not to break it, please. It's not okay to wake me up on a Saturday. So this is getting the request, and it's going to route the request to the appropriate service. So it could be the monolith, if the whatever you're trying to access is still inside a monolith, but if you're trying to build like something new, then it could be hitting one of our new microservices, and the gateway is the one that's making the decision. Do I send this to Rails, or do I send this to one of the Golang microservices that we have? So it's doing the routing, it's going to do authentication, so when you're sending your session cookie, when you're sending your OAuth token, it's being validated at the edge gateway layer. So if I can't find you as a user in our services, I'm just going to say, hey, nope, you can't send a request to the service because you don't have access to this. So it's going to provide authentication, it does logging, does rate limiting, does health checking for the downstream services. And this means that the services that are downstream, they don't have to worry about this. Because I'm going to say, yes, it's this user performing these operations. So the service on the back end doesn't have to know about how am I going to authenticate the user. Like it's happening before a request reaches the back end service.
Load balancer, where is it? Before or after this?
We have it at the two levels. So there's load balancing before the gateway, and there is load balancing, and the gateway itself performs load balancing.
You have multiple gateways?
Yes, we have multiple gateways, yes. And they talk to multiple services. So what we have done here is that there's nothing to be included in your application. Actually, there is one small thing that you have to include in your application, but there's no library. You're not talking to a database. No one talks to the gateway. Like no service talks to the gateway. No one talks to the gateway. It's always the gateway talks to people. Why did we decide to make the gateway talk to people and not have people talk to the gateway? Because they can build their stuff independent of the gateway. Like they don't have to know that the gateway exists. They just get a request. They don't know where it came from, but they're going to trust the request because the request is being served by the gateway. The gateway is going to say the user that made this request, and it's going to, if there is rate limiting, then it should be performed. It's performed at the gateway, so the service knows if I got a request, it's a valid request, and I can serve the request. Like they don't have to worry about all the different pieces, because what would happen, like if you look at other solutions, people are going to build libraries and they're going to give you, oh, this is the library and this library is the authentication service. This library is the rate limiting service. This library is the logging service. What's the problem with distributing libraries? Is that if you update a library, you have to require every single client to update the library as well. And this is a nightmare. Because you can't just go to people, oh, we have upgraded the authentication library. You have to upgrade. People will not upgrade. They have their own timelines. We have many different teams working, and while we work together as a company, we're not working together as one single team. Every single team has its own timelines, has its own release cycles. They have the work that they have to do, and we can't force people to upgrade or to move or to break their stuff just because we are releasing or we broke something. So all of these, what we wanted to do with the proxy and the gateway here for the microservices is that people do not depend directly on the gateway, and all the implementation, all the stuff that's shared across all of the services live on the gateway. And people don't have to worry about it because we have handled whatever needs to happen before a request reaches their services. So there is no library, there isn't anything that people have to do. The only thing people actually have to do, like I am under an NDA, you guys have not seen anything. And what I'm going to show does not exist. This is not a thing. Yeah, just pretend you are not seeing anything here.
Turn the cameras off.
Yeah, turn the camera off.
And close your eyes.
Yeah, so this is basically what people have. They just have something that looks at HTTP headers and pulls information from request headers. This is all the code that people have that depends on the gateway. But it's just like, we could just let them, hey, the headers are named like this, and you just use the header yourself.
do services register themselves with the gateway?
Yes, they register themselves to the gateway. So the gateway was built to be a self-service solution, so people don't have to come to us to do their work. They just register, like they're going to say, oh, there is a route, like /API/droplets, and whenever /API/v2/droplets arrives, you send this to my service. So when you register yourself, you're going to say the path, you're going to say the methods, you're going to say the downstream addresses that I should send requests to. So they don't, like the gateway just maintains a list of all the routes, and when a request arrives, it tries to match and then delivers to the service that's waiting for the service on the back end.
Distributor tracing?
Yes, we do have distributor tracing.
What are you?
I don't know exactly what is running on the thing, but it's on the gateway. It's just open tracing, and it's sending to someone else. We have an internal solution for this, but the internal solution talks open tracing. So there's another team that's responsible for maintaining all the tracing information. So when a request arrives, there is a trace that gets collected, and all the many pieces that happen inside the gateway are listed in there as well. So we can find, when a request arrives at the gateway and goes to the downstream service, if the downstream service also has tracing enabled, so you can see a request with all the different pieces starting from the gateway.
So the outside consumers have to know the URL of the gateway then?
Yeah, because this is only for public facing stuff. So this is what you see when you're using our control panel, like in your browser or when you're making a call to the public API.
What are the potential issues you see if you were to say implement this in Lambda?
Implementing Lambda? There's still state.
Okay.
So like the routes are based on state, so you still have to handle that. So it could be done, like the gateway itself is stateless, but then it needs to pull the routes from somewhere. Right now we use console, so all the routing configuration lives on console. So we could build something that would take a request, and the Lambda function would talk to some storage, pull the routes, try to match the route, and then deliver. Like it's fully doable. Like it's not something that's too hard to do. You can definitely build something like this on Lambda. Like there's no actual state between the service, but then there's the problem that we do maintain long-lived connections, and it's good to maintain long-lived connections in this case because it's really fast. Like there's no TCP overhead to open a new connection. So the fact that the gateway outlives a request ends up making it a little bit better than just using Lambda. So this is like the why. There are no libraries to depend on. People have no dependency on any gateway code at all, and there are no lockstep deployments or circular dependencies. The gateway does not depend on anyone, and people do not depend on the gateway. So the gateway runs if your service is running, and it's going to get requests. If your service is not running, then we're just going to fail with a 500 that you're not there. So the gateway does not depend on people to go up. And people do not depend on the gateway because they don't even know where the gateway is. Because the gateway needs to sit on separate machines due to security issues. Like the gateway doesn't have access to all the stuff that's running on the back end. So even if you get into one of the gateway machines, you would not have access to all the pieces of our infrastructure. So problems is that HTTP is still open-ended and parsing bodies is still under service implementers. So the gateway does not know what comes in the body. The gateway gets a body and sends it downstream. So we're not trying to parse, we're not trying to make sense. So services still have to handle this. So we are still trying to come up with a solution that's going to simplify this. But for now, this is life. You're getting requests from customers, and you should be able to handle the format that's coming in. It's a little bit easier on the Rails end because Rails just knows how to parse the HTTP like body if it's just a form or if it's a JSON, and it builds a single struct on the end. You don't have to know if it's if it was a form or if it was JSON. In our case, since a lot of the stuff that we're building is in Golang, we still have to handle this. So we still haven't come up with a solution for the parsing, and services still have to manage their own HTTP servers. Like, we have tried not to force people down on any way. We use Gorilla for our mux and for our WebSockets implementation, but we are starting to see that people are like, oh, can you make this decision for me? And people want to have something that's easier to manage than just running their own HTTP servers, and we might have to come up with a solution to this. So I'm still unsure if we are actually going to come up with a solution or if we will just let people decide, but we might have to also manage something like this or build a library that's going to be the default that people are just going to use. And what did we look at? We looked at Buchan. That's an API proxy as well. And the problem with Buchan is that there's basically no commits on it. So it has been, it looks like it's dead for 2 years now. So we were like, it's really nice as a project. Has a lot of ideas that we are using ourselves, but like it's just not ideal. And there is fast HTTP, and we did not go that direction because there's no HTTP 2 support, and there are no plans to have HTTP 2 support. So we were like, no. Go standard HTTP server, that's what we use below Gorilla. Like, Gorilla is just the mux. It doesn't actually do any of the HTTP server pieces. And we're using the Gorilla HTTP muxer and the WebSocket solution from them. And we are also looking at GoKit. That's something that would make sense for us to build, either to use GoKit. There are people inside the company that want to use GoKit, but there are also people that look at GoKit and it's like, this looks like Spring in Java. And when you say something like this, people just cringe. They don't want to see Spring anywhere. And if you mention Java, then it's dead. So we don't want to force people to use something like this. As much as like, I find it interesting, but the way it works and the way the APIs look like, the use of interface, it's just like, no, I don't think I want to do something like that. So Gorilla 1, it's fast enough. The muxer is good enough for what we're doing. The way the routes work is really nice, and it has WebSockets, which is something that we are building right now. So Gorilla is really, really nice for building HTTP and WebSocket services. It's really, really easy to work, and there's a lot of support. There's a lot of people working on it. So if you're going to build something on HTTP, I would definitely recommend, if you're building like API kind of stuff, I would definitely recommend you to look at something like this. So why didn't we just use a package solution? Because we need a lot of stuff. Like we needed to customize a lot of the stuff that we were looking for, and all the package solutions, especially like the ones in Go, they do not allow you to just add more Go code. Because before plugins, there was no way for you to load more Go code into a binary unless you actually like build a binary again, and the solutions were not made with this in mind, and they were basically just allowing, oh, you can script with Lua or JavaScript, and we were like, no, this is like complicated stuff. We need to talk to many services. There's a lot of stuff that we need to do on filters and this kind of stuff. So we just like, no, let's just use what we have and try to build a solution. And we thought about using stuff based on Java, mostly like the Netflix-based stuff like Zool. But since a lot of people are doing Golang, we would be the only people doing Java inside the company. And we did not want people coming at us, oh, you're using Java. So we went for Golang. And so it makes it easier to integrate with all the other services that we have and the infrastructure that we already have that uses Golang to do its work. So how does it look? This is what's happening. So if you are a customer, you're here, you send a request, it's going to hit external load balancers. Then this is going to arrive inside the edge gateway. And when it reaches the gateway, it's going to talk to these filter services. This is authentication, this is rate limiting, this is logging, this is a lot of stuff that's happening. Some of this happens inside the gateway. Some of this calls people on the outside to do the work. But from people on the back end, like it's all filters that are running. And then it's going to arrive at what we call a service aggregator, or a backend service. What's a service aggregator in here? Service aggregator is something that collects two or more services on the backend that only speak gRPC and exposes them as HTTP. Like the gateway does not speak anything else other than HTTP. So if there's something coming out of the gateway, it has to be HTTP. But then if your service does not speak HTTP, you are not forced to have an HTTP port or an HTTP server running. Like you can just have your gRPC stuff, and then you build something in front of your services to do the orchestration, and that thing needs to expose HTTP.
So in that example, you're a proxy into a proxy now, right?
Yeah.
So why?
Are you going to lose a little bit of efficiency of your RPC if you're going through HTTP?
Yeah. So why are we doing this? Because some of the services, they work by themselves, and they only make sense together when you're building something that serves customers. So they do not exist together by themselves, like they are separate entities. So they only exist. The only reason they would be like bundled together is like you're creating a droplet and you're getting a volume in place. One thing is creating the virtual machine. The other is getting the volume in place. They only exist together when you're serving a customer. So you don't need gRPC for this, you only need the HTTP piece. So this guy talks to the thing that creates the virtual machine, and then it talks to the piece that creates the volume.
So is there ever like a one-on-one to the gateway to the back end? Like why is it only HTTP? Like did you purposely not have the gateway do RPC?
Yeah, so we did not do gRPC because the gateway would have to depend on all the different gRPC service definitions from all the services. So that would mean that when you update your service, you would have to come to us and say, hey, update the gateway. So the gateway would just be like the main point. What we were trying to do, that's the main issue that we have on our monolith right now, is that every single member of every single team is working on a monolith. So they have to deploy all the time, and they have to be waiting. Oh, someone is going to deploy this, then close, like stop deploying to the service, freeze the service, or like you broke something, and who broke what? Like what page is broken? What change caused the page to break? So the reason we are trying not to integrate the gateway directly with the service is that we don't want the gateway to be like the single point of failure for all the services. We don't want people to come to us when they want to deploy their stuff. They should just deploy their stuff. And the gateway is just going to serve the request. So we're trying really hard not to make like this, if any change that needs to go, we need to sign off on a change. Like people should not worry about us. They should just deploy their stuff, and if it works, like it works. If it doesn't, then it's their business. Like the gateway does not need to change or update because someone else is doing, like is changing their service. So it's the usual filter-based design. A request arrives, it matches against a specific route. This route is going to have a configuration. So it's going to run all the before filters. For this configuration, a filter is allowed to deny or to stop the request cycle. If like the authentication filter is going to deny a request if it doesn't see any kind of authentication data. It's just going to say, oh, nope. This request is not going downstream. Then it goes to the backend service. Like we send the request to the backend service. When the request arrives, there is the after filters. They're also going to operate on the response. And this is mostly like logging. This is counting how long the request took. This is like if there is a failure that happened on the backend service, we're going to eat the response body, because we don't want that response body to leak to the outside world because it's an internal service. So we just provide a usual common error page for this. So there's a lot of stuff that could be happening on after filters, and then we deliver the response back to client. So there's a collection of stuff that runs before, we forward to the service. There's a collection of stuff that runs after the request, and then the client gets the response back for whatever has happened. So there's not much to be done. Filters have their names. There's a do before, there's a do after method, and that's it. Like the actual filter implementation like is going to vary depending on what the filter does. That context is just the request, the response, and a bunch of metadata about the request. So there's not a lot of magic going on in here. This is just usual HTTP stuff. If you're going to build something like this, disable cleaning for URLs on Gorilla. And if you're using the Golang default mux, you also want to do this. Like there's also a way to do this on the default muxer, on the serve mux on the default one. I would not recommend people to use this. It's much better to use Gorilla. It's available and it's much better than the default one that comes on the standard library. But if you're using Gorilla, remember to stop cleaning the URLs. Otherwise, you will get weird errors because people are sending requests and you're not matching the URLs because it's cleaning the URL. So what about the proxy client side? So for the communication from the gateway to the downstream services, remember to limit everything. Like I spoke about this on our last meetup on HTTP clients, and the defaults for Golang's HTTP clients are awful and sad, and you're going to regret if you do not set these defaults. Like they are awful. Like do not create an HTTP client in production and use the defaults. Like it's going to bite you. So this is how it looks when you're actually setting up all the defaults. This is basically what we use. So you want to have dialers, you want to have the TLS handshake, you want to have the expect continue timeout, you want to define max idle cons. So a lot of this stuff needs to be defined. Like the defaults are not okay. Please do not use the defaults. If you get a response, close the response. If you're making an HTTP request and you got something like there is a response in here and there is a body, go there and close the body. If you don't do this, it's going to be alive and then it's going to wait for the other side to close the connection, and you will not reuse this connection. So if you don't close it, if you don't read it to the end, so you have two steps to do here. You have to read the body to the end, and you have to close the body. If you don't read the body to the end and you only close, this TCP connection is not going to be reused. And if you forget to close, then you're going to have a dangling connection in here, and this is just going to be a file leak on your server. And you don't want this to happen. So if you're building an HTTP client, make sure you're doing this on all of your responses. When you're doing health checking, this is just like the kind of stuff that we have learned. Don't reuse connections, because if you have a health checker and you are reusing connections and you are connected to something that changes over DNS, what's going to happen is that the health checking connection never dies. It's going to be there forever. So if the DNS changes, you will never pick up the DNS change. So when you're building a health checker, close the body, close the connection, and always create a new connection. Set the user agent. This is also something that we have learned, because we were sending a lot of requests to downstream services to do health checking, and they were like, what is this thing that's sending all of these requests to us? It just says go. Like there's no definition of what it was. It was like, oh, okay, so we're not sending a user agent. So now this sets the user agent of the gateway health checker, so that people know this request is coming from the gateway as a health check. So they can like remove it from the logs or something like this. Set timeouts, like don't forget the timeouts, especially now that we're all on Go 1.8. Use the context, set the timeout for your context, and let that timeout go for the connection. If is your application going to require you to be running an HTTPS, like a Rails app, like what we have in there, make sure you can override the headers, so the X forwarded proto in here is needed. Otherwise, when you send the request to Rails for the health check, it's just going to fail. And log the actual error. So when you send a request to a health check and it fails, make sure you log in all the information, because people will want to look at this. People will want to understand how the service is failing, why it's not health checking. So make sure all of this is logged. Have metrics. Like it's really easy to collect metrics for all of this stuff if you have something like a proxy. in front of here. If you have a proxy that's sending the request and making all of this work, you can collect metrics like based on URLs, based on routes, just general metrics. Like you can use as much information as you can because you have this service that's not doing anything actually. It's just forwarding the request to something on the back end so you can collect all of these metrics. And the proxy is always to blame. So whenever, if your service is not responding, people will always come in and say, oh, is the gateway broken? That's the very first question until we go there and say, oh no, it's your service that's broken. It's your configuration that's broken. So if you're building something like this, make sure there is an easy way for people to look where stuff is broken. Like how far can a request go? Where are requests being lost? Where am I getting this error? Like is it the gateway? Is it my service? So make sure this is visible for people on the outside. People don't want to be tailing logs to figure this out, especially on distributed systems. Like there's no reason for people to be looking at logs to figure out this information. You need to have a high level view of the services and understand how the services are behaving. Make sure troubleshooting is easy. If you're building microservices and you want to understand what's happening, you need distributed tracing, you need logging, and you need high-level views for people to understand what's happening to the services. Like if you're building microservices and you're not worried about all of these things, you're in for a world of pain. It's going to be awful. Like don't do this. Like continue running on a monolith because it's working for you. If you just move to microservices because microservices and you don't worry about all of this stuff, it's going to be a nightmare. Limit connections. Go standard HTTP client does not limit connections. So you have to build a dialer that limits connections to the client. Otherwise, it's just going to create more connections and more connections and more connections, and then it goes out. Then your service is not going to work.
How do you scale your gateway?
Right now, we just get more machines in place.
Oh, so you're not even using containers or anything like that?
No, not for the gateway. We do have most of the applications that are behind the gateway run on Kubernetes, but the gateway itself does not. The gateway itself runs on actual machines. We might move them to Kubernetes, but I'm not sure if we're going to do this right now. Right now it's just running on actual machines, just like our load balancers are running on actual machines as well. So how is it going? We serve almost all traffic to DigitalOcean properties. So if you're making a request to any of our services or any kind of interaction to the control panel, it's going through the gateway. There's no change in functionality for customers. And the gateway is not supposed to be visible for people on the outside. The gateway is only visible internally. So that's a good thing that hasn't been any like site-wide issues because of the gateway. Well, we do have issues, like we still haven't like taken all of the pieces down. We have logs, metrics, dashboards for all properties behind it. So if you have something running behind the gateway, you get a dashboard just for you, for your service behind the gateway. So you can just use that. So we are still working on documentation and examples, and this is one thing that you have to worry about when you're building infrastructure inside of your company. You will have to build documentations, you will have to build examples, just like any kind of project that you want developers to use. So like there's no way people are going to be using something internal if there are no docs, there are no examples, and people do not understand how to use it. So if you want to build something like this, you will have to get something out there. And there's very little performance impact from the gateway itself. We collect metrics on how the gateway behaves and how much overhead it introduces. So far it has been really, really small for all the stuff that we are building on top of it. So it's been really nice to build this. So any more questions?
I might have missed this, but are you doing transformations of requests and responses that you're getting back and forth in the gateway?
Not the bodies. The body that arrives, unless it's a failure that's coming from a backend service. If it's a failure that's coming from the backend service, we just remove the body and set a default error back. That's the only place where we are touching the bodies.
This has got to learn something. What is a MUX?
The MUX is the thing that gets a request and delivers it to something. Like it's just a router. So it gets a request, looks at the path, looks at the host, and then delivers it to some function that operates on it.
That's all it is a router?
Yeah, it's just a router. It's just that in Golang they call it MUX. I'm not sure exactly.
Oh.
Yeah.
Multiplex?
Oh yeah. But it's basically just a router.
How do you decide when to use HTTP2 versus gRPC?
If it's something for the gateway, it has to be HTTP. If it doesn't speak to the gateway, then it should be gRPC. Yeah. So right now, most of the stuff that we're building is gRPC. We are having one of the things that we found out, and it's like kind of complicated, is that gRPC for Ruby, which is our second main language, is awful. So if your folks are planning to build stuff on gRPC, pay attention that gRPC, and you need to integrate with Ruby. gRPC with Ruby is not ideal. So it might be a bit more complicated. So for the Ruby stuff, we are also we're trying to use gRPC, but sometimes it's too painful, and we just build HTTP. But most of the new stuff that's being built, and that's being built on Golang, it's all gRPC.
What are you guys using to load test it?
We have internal tools to do it right now.
Machines, right?
Yeah.
You guys use something like console or NCD or state? Like, how do you keep track of all your backends?
Yeah, so this lives on console. Like all the routes, they live on console. So the gateways are talking to console.
So console's the one doing the checking on them. If they're healthy or not.
No, we only use console as a KV store. Yeah, console is just a KV store for us. We don't use the other pieces of it.
What's your testing strategy for the gateway, unit testing, integration?
There is unit testing for all the code. It's all the code is unit tested, and when we're running, no one has seen this. This is not happening. Let me see if it opens in here. Oh no, it's not going to open. It's not going to work. I'm not on the VPN. But what happens is that the gateways, we actually have two separate sets of machines. And when we're running a deployment, you deploy to the set of machines that is inactive. Then we run smoke tests on these machines. And then if the smoke tests are green, then these machines get promoted as primaries. And then the older machines are taken out of rotation. So you always deploy to the set of machines that's not serving requests right now. So you deploy, you run tests on the machines, and then you flip the switch.
This is like Kubernetes.
Yeah. So all of the other services, we have our own internal tool that does Kubernetes management, and everything runs on this but the gateway. So it would be great if the gateway was running on this, because then I would not have to worry about it. But we can't run the gateway on this infrastructure right now, but this is something that would be really nice for us, because that means we don't have to worry about the machines ourselves. Okay, so you go.
What kind of statistics do you show on the dashboards that you talked about?
So we show request rate, we show how fast your services are responding to requests, we show how many requests the gateway itself is serving, we show error rates. If the gateway is erroring, we have metrics and alerts on top of the fact that the gateway is erroring. We show the time connections take to happen. If some of the services are slower, then the Ruby services are not as fast as the Golang services. So there are many more connections to those. So we pay attention to how many connections we have to those services. So it's
just aggregates?
Yeah, it's just aggregates. So
That's a great feature. When you say microservice and monolith, are you referring to a software design pattern? And when you're implementing microservices, when and how should you do it?
It's there's no definition on when you should go for microservices. It's hard to define when something should be built into microservices. But for us, it's right now, teams are organized on top of features that we expect to exist in the cloud. So if you are building a feature, for instance, we just released load balancers. So if you're building something like that, we're trying to build these features and these pieces as services themselves. So they exist independent of the monolith that exists right now.
And what do you mean by monolith? Is that just like...
The monolith is like the single application that we had in the past that does everything. So it does, like, it creates droplets, it set up volumes, does networking, does all the pieces. It's all together in one single Ruby application, and it's really hard to maintain the single Ruby application.
And you're using the microservices to break it up?
Yeah.
So how are you kind of, in your testing, kind of like mocking those backend services and all the failures that happen? Is that just a unit test?
Yeah, so we have unit tests for that, and we have one special service that we call the echo service, that any HTTP request that you send to this specific service, it just replies with a JSON format of the request that you have sent. So what we do is that some of the smoke tests are going to send request to the gateway that should be routed to the echo, and then we verify that all the headers that we were expecting to see, for instance, we're sending a request to a path on the echo server that should have authentication. So if I don't send any authentication details, the request should fail. If I do send authentication details, then I should get back on the body all the authentication details that I'm expecting. So I'm just validating that, yes, I see the user that I expected to see on this. So all the functions, all the filters have something like this on our smoke tests to make sure that when we're deploying, these services are actually like running. And we also, like, our smoke tests include like the most important piece of the infrastructure, that is create a droplet. So if this fails, the smoke test, like, just no. Like, if you're not creating droplets, you should not go to production. So it's basically like test basic functionality, actual like website functionality to make sure that's okay, and also testing gateway functionality. And it runs like the smoke tests are for every single server that's in there. So we have a collection of servers that like we call the alphas, and we have a set of servers that we call the betas. So the smoke tests are going to point to every single server, and they're going to run against every single server. So if one of them fails, like the smoke test also fails, and we do not perform a deployment.
You use Jenkins?
No, we use Concourse. Yeah, we use Concourse and GoCD. Yeah, Concourse and GoCD.
Sounds like Go is really popular at DigitalOcean. Like, where are some of the features of Go that, you know, make it a really appealing language?
I think like one of the main things for us is the single binary. Being able to just build a single binary and deploy that single binary makes a huge difference, especially when like we're deploying to our Kubernetes stuff. It's really easy. We just get a vanilla Ubuntu image and we stick a binary on it, and it just runs. So that has been like the main thing that we have been like seeing as something that makes a huge difference on operations. But like the language is statically typed. There's a lot of libraries available for the kind of networking stuff that we do. And like concurrency is really easy to handle on it. So in terms of like for building backend and API kind of stuff, it's really, really useful.
My mind may have been wondering, so you may have covered this already. Are you able to use, break things up so that you could theoretically send a request through the monolith, and then send a similar request to the microservice and compare the results?
We don't have like functions that exist on a monolith right now. Actually, we do have one of this. We have one case where this is in there, and it should have been removed, but but it's still there. Like, it should have been removed from the monolith, but we have something like when you open the control panel, that control panel that you see on DigitalOcean is an Ember app, and it's served independent of the Rails app. It's calling the Rails app like as an API, but it's an Ember app that you just download. You just download the JavaScript and it runs, and it checks for the version, like if you need to update a version of the application. This request used to go to the monolith, but now it goes to a microservice that defines the version of the Ember application that you're seeing. So we went, before flipping this solution to the microservice, all the users that are DigitalOcean employees were sending requests to the new service, and if you were not an employee, you would be going through the monolith. So that's how we tested, like it is actually doing what we expect it to do. And we also did this for authentication to make sure that if the Rails app says the authentication is okay, the gateway should also say that the authentication is okay. So we did this for a while to verify that the authentication code that we wrote was matching the Rails piece. And once we found out like it is matching, and it is like when Rails says that the user has a session, we are also saying that as a session, then we flipped and we just removed the need to verify on Rails. So that's just something that when you're building and when you're migrating something like this, you just have to do, just to make sure that the new code is actually behaving the same way as the old code, especially because we're moving languages. So there's no way we can load Ruby code into Golang to do this work. Yeah.
So how many servers did you get back?
So it's like when we moved like this is specific thing, that's the version check that's not going to Rails. Like it was like 20% of all the requests on the Rails app stopped to go there, and they're just going to a Golang app that just talks to Redis and verifies the version, and it's wildly faster. So right now it's still a slow process. We're still trying to convince people, like if you have something that's on a monolith, please move it out. So it's hard to move existing stuff because we are building a lot of new features, we're building a lot of new stuff, and it's hard to go back and try to fix what's in the monolith. But all the new stuff, people just don't want to touch the Rails application anymore. They just want to build all of this stuff on the gateway, and it's been really nice for people to do it like this.
Has moving to sort of like, I guess, like the router-based paradigm for you guys given you more operational intelligence? Like, you know, like figuring out things that were going on that you didn't know were going on beforehand?
In a way, yes, but I think like tracing has made, if we had tracing from the beginning on the Rails app, we could see kind of the same information in there. But since we did not have tracing on the Rails app in the beginning, like we did not have this information. So I think at the end, tracing was much more important than the gateway. The gateway can provide a lot of information about the aggregate. We do not like collect route specific information on the gateway because for the API, for the public API and the cloud application, we just have catch-alls. So there's no way the gateway knows every single request. And since we use like RESTful URLs, if we try to collect from the path, we would just have like a lot of metrics that are basically useless. So the gateway does not understand the routes in this sense yet. We want to get to a point where the gateway is actually going to have very specific routes. There's going to say path and method and all the pieces, so that we can also we only do like authentication, we do not perform authorization. There's a separate service that's performing authorization right now, and people have to call the service. But we want to eventually get to a point where the authorization piece also happens on the gateway. But for that to happen, the gateway needs to know all routes to actually perform this kind of validation. So this is something that we want to happen in the future, but it's not like we are still like going in that direction.
You said that each of the services needs to call to the gateway to register itself, right?
Yeah.
So let's say you have to restart the gateway, lose your state of routing. Like, how do those clients know that they need to re-register?
So the only way we would lose all the routing configuration is that if the console cluster goes away, because the routing configuration lives on console. So the gateway does not have the state by itself, it pulls the state from console. So whenever the key changes on console, the gateway goes there and then pulls the configuration. So if console went away, then it would be a huge issue because the routing goes away. But we do have backups for console, so we could just restore from the backup. So
every service doesn't need to do periodic re-registration?
No. You only register when you have something new happening. Even the registration code is going to, if there's nothing new on the service, it's just not going to run because there's no difference.
Cool.
Yeah. So I guess we...
Yeah, last question.
Yeah, last question, there we go.
Could you elaborate on what some of the issues that Ruby has with using RPC or gRPC?
Yeah, so we were trying to do gRPC server in Ruby, and one of the things is that concurrency is not well defined, so it's hard to use something like active record, and it's hard to reuse connections. When you have a gRPC server running in Ruby, most of the time if you're using something like Unicorn or Puma, they're going to fork the process, and the gRPC solution does not allow you to fork. So since it doesn't fork, you would have to have one single Ruby process on every single port, and you would have to, like when you get a request, you would have to just look at all the ports available and send a request to one of those. So it's really complicated to build a solution like this. So what we did at the end was that there is a Golang gRPC server that talks to a Ruby application using HTTP. So the Ruby application runs on Puma, and it does forking as like any Ruby application would do, but the gRPC server in Golang is the one that's like parsing the gRPC stuff, and this made it much, much faster than going straight gRPC with Ruby. Like we had benchmarks, and the benchmarks make no sense. The Ruby solution should at least be like close to the Golang solution, but this Golang solution where Golang parses the gRPC and talks to Ruby is 4 times faster than the Ruby solution. So the gRPC code for Ruby is definitely, it's not ideal. And we didn't want Google does not use Ruby, so I'm not sure if they care. So like they have said this before, like, oh, we don't use Ruby, so if you folks want to come here and fix it, like it's fine. And we were like, no, we don't want to invest our time into building something like this. We can just have a Golang gRPC server talking to Ruby, and it gets the job done. Yeah, so that's it. Yeah, check our page. We don't have a Philadelphia office, but half of the company is remote. I am remote. I am in Philly, and I don't go to New York every day because this would just be insane. So I just work from home, and if you wanted to apply and check it out. We have offices in New York, and we have an office in Cambridge, Massachusetts as well.
Sweet.
Thanks for coming.
Yeah, guys, thanks for coming.
Yeah.
Again, anybody